Hi guys, today we're going to look at a video that is going to cover the material that you missed on Friday from the 1014 notes on specific probability distributions. So first let's just look through these really quick. Binomial and geometric are very similar. They both have two possible outcomes. The difference is that binomial is counting the total number of successes, whereas geometric is what we call a wait time. And you're waiting for something. So it's like how long until or before something happens. Okay, whereas here it's talking about something like exactly or at least or at most. So at least, at most, something like that. So calculator sort of stuff you should know here. Second bars. Binom PDF means at an exact point. That means when you have an equal to sign. CDF stands for less than or equal to, when x is less than or equal to some number. Okay, so both of them require that you have an equality. These symbols, really quick, x is the number of successes, so it's a whole number. P is a probability, Q is a probability of failure, so to get Q, it's 1 minus P, N is your number of successes. This is a large whole number. And we use the same exact symbols. That's it, how? Whole number. We use the same symbols for geometric. Okay, so exactly the same. And then when we move on to looking at, instead of geometric, the normal distribution, we're very familiar with this. Way back when, from when we had a z-score equals value minus mean over standard deviation. And you recognize it because it's going to say something is normal. And you'll be given a mean and a standard deviation. Sometimes you're also given a sample size. If given n, then your z-score is then value minus mean over standard deviation over the square root of that sample size. So TI-83 commands, normal CDF, inverse norm. Normal CDF will give you a percentage. Inverse norm you use when you're given an area or a percentage. So let's look at some practice problems. Actually, before that, let's look at your formula sheet. So stuff you're given for binomial, these are the means and standard deviations of a binomial. These here are the mean and sample means of a sampling distribution. That means if you took many samples, the sampling distribution of p hat. So sometimes these come up in multiple choice questions. Then we also have this sort of thing that I just mentioned if you have a sampling distribution for the mean. Sampling distribution for mu. Excuse me, for x bar. Okay, and then you are given the z-score formula, but they just say it this way, which is a little bit different. So starting off with the first one, the heights of adult women are approximately normal. As soon as I see that, I know I'm going to be drawing a normal curve. We have the mean of 65, standard deviation of 2. Rachel is the 99th percentile. Percentile means percent below. So I'm starting with the picture. 99th percentile, well, if she was here, 50% would lie below. So here, that shaded area there is 0.99. Center 0. I don't know what that z is. So what I'm going to do is inverse norm of 0.99, and I get 2.33. So all I have is one formula here, value minus mean over standard deviation. So I know my z-score, 2.33, equals the value that I'm solving for. I don't know how tall she is, minus the mean over the standard deviation. If you cross multiply everything by 2, yada yada, you should get her height to be 69.66 inches. So she's closest to 70 inches tall. Okay, number 2, the probability of obtaining a head when flipping a coin is 65%, so it's not fair. Which of the following is closest to the probability that heads would be obtained 15 or fewer times? So we have the probability of a success here is the probability of heads is 0.65. So the opposite of that is 0.35. I want to know the coin is flipped 25 times. That's my sample size. And I want to know what's the probability if I'm going to say x equals the number of times you see a head. What's the probability that that number of times is 15 or less? So it's a binomial. Either you hit heads or you don't. When you have a less than or equal to, it's CDF, so binom CDF. And what I like to do is put a line underneath my C because I know then that matches with the less than or equal to. And the order for this is NPX. So my N was 25, my probability is 0.65, my X is the 15. So if you type that in your calculator by hitting second bars and going down to the bottom binom CDF, you type in 25, comma 0.65, comma 15, and you get out 0.3696. So looking here, 0.3696 is closest to choice B. Okay, question 3. 10% of dynamite mints are orange. Okay, 45% of holiday mints are orange. So already there's too much information. So I have dynamite, and we have probability of orange is 45%. Then we have holiday, and then for them the orange candy is 45%. Oops, I already messed this up. Dynamite is only 10% orange. 2 independent random samples. We always like samples to be independent of size 25. So we have n equals 25, n equals 25 are selected. The total number of orange candies in the two samples are observed. So we're counting orange candies. What is respectively? We are looking at the expected total number of orange candies and the standard deviation. Okay, so looking at this one, how can you figure this out? Well, this is a binomial situation. Either it's orange or it's not. So the mean you're given is n times p. So we're going to have to figure out the mean for each of these. And then the standard deviation, you're also given square root of npq. This is on your formula page that we just went over. If you go back, you'll see that. So if we plug in this n and this p into this formula, we get a mean for dynamite of 2.5 orange candies. If we plug in all our numbers here, we'll get a mean and a standard deviation of 1.5. For holiday candies, this is our P. That's our N. So our mean here is 11.25. Our standard deviation is 2.487 something, something, something. So each of these is binomial. Now we want to find the expected for the total. So means we can add. So the mean of, let's say, dynamite plus the mean of holiday, we're allowed to add them. We get 2.5 plus 11.25, and that gives us a total of 13.75. So that's great. That gives me, I'm down to C and D. Standard deviations, you have to remember that variances add. Always. So I'm going to look at their variances. So I'm going to say, okay, to get the new standard deviation, I'm going to say, okay, 1.5 squared plus 2.487. I'm going to use that whole thing, square that, and then to go back, take the square root. Should get 2.90433. Don't round until the very, very end. So what's that closest to? It's closest to this one. So D. So again, this is using probabilities and this idea of variances adding that comes up a lot in sort of multiple choice and combining random variables. Question 4, moving on, is a recent study conducted to investigate the duration of time required to complete a certain manual dexterity task. The mean was 10.2 with a standard deviation of 16. Suppose the reported values are the true mean, so that's why I'm using the Greek letters. For the population, so Greek letters again, if a random sample of 144 subjects is selected from the population, what's the approximate probability that the mean of the sample will be more than 110? So the probability that the mean of the sample mean, will be over, 11, not 110. Well, since this is greater than 30, we know our data will be nearly normal. We're talking about means. So first thing we start with is a z-score. 11 minus the mean of 10.2 divided by the standard deviation. But since we have that n, we need to take that into consideration and divide by the square root of n. So we get our standard z-score to be 0.6. Second step, draw the curve. This is multiple choice, so you wouldn't have to, but you should know that you're shading above because it said more than. This is 0.6. And then we would do normal CDF as our third step. CDF, we never use the PDF, and you'd be typing in 0.6 comma 100 because we're shading all the way up here. And if you did do that, you would get choice B. Okay, a few more left. Number 5. You can tell right away that you're using formulas. So right here, you should say, okay, look at the formula sheet. That's what you should be saying. You're not actually asked to solve anything. So in this one, we're told a recent survey concluded the proportion So we know we're talking about P. Of American teenagers who have a cell phone is 27%. The population proportion is 29. So we have population proportion is 29. The sample proportion is 27. For samples of size 1,000 are selected, what are the mean and standard deviation for the sampling distribution of the proportion? You are given on your formula sheet, you're given these formulas. We just looked at the mean of p hat is p. Standard deviation of p hat equals the square root of p times q over n. So for us, this is going to now be 0.29. So automatically, A, B, C are out. For here, we're going to be saying the square root of 0.29 times 0.71 over, and our sample size is 1,000. So it's D, sampling distribution of the sample proportion. So they're talking about of p hat. Okay, so that's all I wanted to look at for today. If you have any questions, I will have extra help, and I hope that all your exams are going well.